guys, my name is Mukesh Ahuja and we were discussing magneto-hydrodynamic power plants in the subject of renewable energy engineering. So in that we have seen few design and development problems for developing MHD power plants. So the main issue for developing the power plant is that the material selection becomes very crucial because the material life gets deteriorated due to the gaseous gaseous forms ionized gas which will move inside the generator, so due to which the material becomes very much important factor. So today we are going to discuss what kind of material is required for MHD generators and why this power plant is not widely used because of its materials. So the materials used in the construction of MHD plants must have first, as you know that this power plant works on very high temperature, therefore high temperature resistance means it should withstand very high temperature and should not melt on or should not deteriorate on high temperature. So its life cycle should be high. Also high temperatures combined with high temperatures plus alkaline atmosphere. Also alkaline atmosphere due to presence of seeding materials makes this MHD duct extremely susceptible to corrosion. So due to this alkaline atmosphere, it can be suspected to corrosion. So the selection of the materials is very limited due to the stringent environmental conditions. So the important factors to be considered for the selection of materials are, so first as we have seen is high temperature resistance, second is alkaline atmosphere, therefore we can say it as corrosion resistance, third we can say is that electrical conductivity, that it should be conductive. Then fourth is erosion resistance, so the material should not be eroded. Eroded means that the particles should not be removed due to the movement of the gaseous particles of high velocity, so it should be erosion resistance. Then fifth is its melting point of the materials, so the melting point of the material should be very high, so it is very much important. Then sixth is oxidation reduction resistance, means oxidation and a reduction, that as we know that there may be possibility of oxidation and reduction, means oxygen and hydrogen, so therefore it should be inactive towards the oxidation reduction. And seventh is its density, so it should be denser. So these are the main characteristics which are required for the material. So to obtain such kind of material is very much difficult and very limited criteria are there to select this material. So now we will see the other materials which are required in the power plant. So so the other components which are required. So which are the components? So let's see for that electrode. So suppose the high conductivity, high temperature is required for this electrode. So the material should be electrically conductive, structurally stable at high temperature. Refractory materials like nitrides, borides and carbides are suitable materials. So for electrodes, this nitride, boride and carbide can be selected. Second, for duct liner, which material we can select? So for duct liner, it is cooler than electrodes. So the materials must be both electrical and thermal insulator. So here electrodes should be as you know conductive, but duct liner should be resistance to conduction, means it should be insulator. So electrical and thermal insulator. So it should be electrical and thermal insulator. So the insulating materials used for duct walls are magnesium oxide and strontium zirconate. So strontium zirconate and etc. So MHD ducts have to withstand a temperature in the range of, so they have to withstand a temperature in the range of 300 not but 3000 degrees Celsius. So presently steam cooled walls which are made of insulated laminations of very thin nickel or stainless steel have been tried. The research is on to use suitable ceramics or coatings of ceramics to use as duct materials. Third, so now what is third? Third is magnet. So it is stringier than permanent magnets. So ferromagnetic cores can be provided. Superconducting magnets can also be provided, which are very little current. So for magnet, ferromagnetic cores, ferromagnetic cores can be provided, and superconducting magnets can also be provided. This superconducting magnets can also be provided with use of very little current. So these are the components where the materials are used. Now we'll see the future of the MHD power generation. There is future prospects that where MHD generation has potential and where the MHD generation is ongoing project. So we'll see the future of MHD generation. So the future of MHD generation. So the first 25 megawatt MHD pilot plant was commissioned in the erstwhile in USSR in 1970, which has successfully supplied electricity to the Moscow grid. It was followed by 1000 megawatt capacity plant 1000 megawatt capacity plant near Moscow in 1981. So a pilot 250 megawatt engineering test facility which is planned to be fully integrated MHD steam power plant is commissioned in USA. So a major countries involved with MHD activities are, which are the major countries? So there are Russia, USA, Japan, Australia, China, India, Italy, Israel, and Poland. So these are the 9 countries which are involved in MHD activities. So let's talk about India. So in India also considerable studies have been carried out in the field by a team of scientists under the National Council of Science and Technology, that is NCST. The Department of Science and Technology of Government of India has sponsored research and development program on coal based MHD power generation. This coal based MHD power generation. Then BARC, that is Baba Atomic Research Center, in collaboration with BHEL, this Bharat Heavy Electricals Limited, and Institute of High Temperature, Russia, is also executing research and development in the field. Under Joint Russia Program, a prototype MHD generator having 5 megawatt thermal input with coal gas as a fuel. So these are the institutes where the MHD generation programs are held. So in Russia, uh, it is executing research and development. So under Joint Russia program in India, a prototype MHD generator having 5 megawatt thermal input with coal gas as fuel, which uses a seed of 50 percentage of K2CO3, that is potassium carbonate, in water has been built at BHEL. So this has been built at BHEL, that is in Trichy, Tamil Nadu, in collaboration with BARC, that is Baba Advanced Research Center, Mumbai. So MHD generation looks the most promising of the direct conversion techniques for the larger scale production of electrical power. So this is the prospects of the future power generation using the technology of MHD, that is magnetohydrodynamic. So as you can see that the main concern for generating the power is the selection of the material, because many properties are taken into consideration due to its very corrosive and very high temperature environment. Therefore the life of the material becomes very much important, because we need not to replace the material again and again, so it will create a very high cost, and also it will create very high, it will require many so much manpower. So the selection of the material should be very much important in this MHD power generation, due to which the gen- due to which the mainly the the popularity of this power plant is very much less, but also it may gain popularity when it shows much high good results, because the initial cost of the materials will be very much high. So the we will also we have seen all the aspects of MHD power plant. So this was the last topic of the MHD power plant. So I will just revise once again. So which topics we have seen? So first we have seen the principle that it works on the Faraday's law, that when an electrical conductor moves across a magnetic field, a voltage is induced in it which produces an electric current. So that is the Faraday's law. and then we have seen that force is induced, and we have then also seen that power output of an MHD generator, that how much output is there of an MHD generator. Then we have seen the thermal efficiency of the MHD cycle, and then also we have seen one example. Then we have seen open and closed cycle system, that is MHD systems is open and closed. And then we have seen advantages and disadvantages of MHD plants, that why, what are the advantages, why it should be used. So there were many advantages, and the disadvantages are very less, but it is very much important. One or two are the disadvantages, but it has very much impact on the development of the MHD design. There is problem in design and developments. Then we have seen the then we've seen that magnetic field strength, that is power output of an MHD generator, is directly proportional to the magnetic field strength, that is B square. But the stronger magnetic field is desired for more power output, but it has some limitations for getting higher magnetic field. We have some limitations. So these are the concepts, various concepts and various topics you discussed. So now, and also then we have seen the future prospects of the MHD power generation. So this ends the chapter, and this also ends the non-conventional energy sources or renewable energy engineering. So thank you very much.